In this question, we are provided with a 2 by 2 matrix and the condition that a sub squared is equals to lambda times a. Using this t information, we have to find the value of lambda. So we begin with the matrix A is equals to 3, negative 3, negative 3, 3. So here we say that each entry is a multiple of 3. So what we can do is we can divide each entries by 3. So that should give us 1, negative 1, negative 1 and 1. And what we can do, since we divided by 3, so we have to multiply by the scalar 3. So this is the value of matrix A. Then we find out the value A sub squared. So A sub squared will be A multiplied to itself. So we write down the matrix 3, 1, negative 1, negative 1, 1, and then multiply it to itself. 1, negative 1, negative 1 and 1. So that should give us 3 times 3 is just the scalar multiplication, that is 9. And we have to multiply 1, negative 1, negative 1, 1 to itself, which is again 1, negative 1, negative 1, 1. So A sub squared is equals to 9. We perform the multiplication, so that should give us, for the first entry, which is the element in the first row, first column, what we do, we consider the element in the first row of the first matrix and multiply it to the element in the first column. So that should give us 1 plus negative 1 times negative 1 is positive 1. Then similarly we follow the steps of multiplication. Then this should give us negative 1 times negative 1. In the second row we have negative 1 times negative 1 and 1 plus 1. So this will be 9, 2, negative 2, negative 2, negative 2. So again what we do is we divide. Each entries by 2. So that would give us 1, negative 1, negative 2 and negative and positive. This is negative 1 and 1. And since we're divided by 2, we have to multiply by the scalar 2. So 9 times 2 is 18. So we have a squared is equals to 18. And this simply is 18. Okay. Now it's given that a squared is equals to lambda times a, which is equals to 18, 1, negative 1, negative 1, 1. So we have to find out the value of lambda. So here we see that this matrix is actually 1/3 of A. So that means we can write lambda A is 18 times 1/3 of matrix A. So this is lambda A is 9 times of A. So when we compare both sides, we'll get lambda is equals to 9. So that's the value of lambda. Let's go to the next question. So here we are given a matrix expression and we have to simplify it. So what we're going to do, we're going to multiply the cosine theta, which is our scalar, to each entries of the first matrix, and similarly sine theta will get multiplied to each entries of the second matrix. So that should give us cosine squared theta, and we have cos theta, sine theta, and have minus of sine theta, cosine theta, and cos squared theta, plus we have sine squared theta and minus of sine theta, cosine theta, times positive sine theta, cosine theta, and sine squared theta. Now, since the two matrices are of the same order, we'll add them up. So the first entry will be cos squared theta plus sine squared theta. The second entry will be cos theta, sine theta, minus sine theta times cos theta. Here we have minus sine theta times cosine theta plus sine theta times cosine of theta, and then in the 4 times 3 we'll have cos squared theta plus sine squared theta. Okay, so this should give us the cos squared theta plus sine squared theta. That's an identity whose value is always 1. The second entry, they cancel out each other, leaving us with a 0. Similarly, the third entry 0, and the fourth entry we have 1. So this is the identity matrix. So the simplified value of the given matrix is equals to I. So that is the answer. Let's go to the next one. In this question, we have to find the value of x for the given matrix equation. So what we do, we're going to multiply the first matrix to the second one. So that should give us 2 times 1 is 2, plus 3 times negative 2 is negative 6. So this will be 2 minus 6. Then for the second entry, what we do, we take the first row and multiply it to the second column. So that will be 2 times negative 3 is negative 6, plus 3 times 4 is 12. Then for the third element, what we do, we take the second row and multiply it to the first column. So we have 5 times 1 minus 14. Now we have negative 15 plus 28. So this matrix is equals to negative 4, 6, negative 9, x. So let's simplify the values. So 2 minus 6 will be negative 4, minus 6 plus 12 will be positive 6, 5 minus 14 will be negative 9, and negative 15 with positive 28 will give us 13. So this is equals to negative 4, positive 6, negative 9, and x. Now we see that all the corresponding elements are equal because it's an equal matrix. So that means that the value of x must be equals to 13. So that's the value of x. Right, next question. So here we have, it's a very similar question. So we have to find the value of y minus x. So what we do, we begin by multiplying the scalar to each entries of the first matrix. So that should give us twice x, 10, 14, 2y minus 6, plus 3, negative 4, 1, and 2. So this is equals to 7, 6, 15, 14. Then we add the first two matrices because they are of the same order. So that should give us 2x plus 3. This is 10. So 10 minus 4 would give us 6. 14 plus 1 will give us 15, and twice of y minus 6 plus 2 would give us twice y minus of 4. So this is equals to 7, 6, 15, and 14. So we take the first entry, 2x plus 3, and equate it to 7. So that would give us twice x plus 3 is equals to 7. So solving for this, we'll get twice x is equals to 7 minus 3, which is 4. So that gives us x is equals to 2. Then we take the fourth element and equate it to 14. So this will be 2y minus 4 is equals to 14. So we have twice of y is equals to 14 plus 4, which is 18. And we have y is equals to 9. So now that we have the value of x and y, so we can find out what's the value of y minus x going to be. So that is going to be 9 minus of 2, which is equals to 7. There you go. So that's the value of y minus x. The next question. Very similar to the previous question, we have to figure out what's the value of x. So we begin by multiplying the scalar x to each entry of the first matrix. So that would give us twice x and thrice x. Plus, for the second matrix, we do the similar thing where we multiply each entry by the scalar y. So that will give us positive y and negative y, a column matrix. And this is equals to 10, 5. And we can see that the first row column matrix will get added to the second column matrix. That would give us 2x minus of y, and in the second row we have thrice x plus y. So this is equals to 10 and 5. So we equate them, then that should give us twice x minus y is equals to 10, and thrice x plus y is equals to 5. And we have to find out the value of x. So what we do is we label them as equation number 1 and equation number 2. So we're going to add those equations. So we take equation 1 and add it to equation number 2. And let's see what we get. So 2x minus y is equals to 10. 3x plus y is equals to 5. This is 10. So we add them up. So 2x and 3x adds up to 5x. Negative y and positive y, this will cancel out each other. 10 and 5 gives us 15. So x is equals to 15 divided by 5, which is 3. So that's the value of x. There we go.